In this video, we are going to look at some examples where we find some absolute extrema of some functions on some different intervals. Right, let's look at our first example. F of x equals 3x to the 2/3 minus 2x. And we're looking at that on the interval from -1 to 1. So if we're going to find absolute extrema, we are going to need to find our critical numbers. To do that, we will take our derivative. F prime of x is 2x to the -1/3 minus 2. Get a common denominator between these two pieces, and you will have 2 minus 2 cube root of x over the cube root of x. And so we're going to have critical numbers. Critical values are going to be occurring at 1 and also at 0. And so if we were to solve the top, set it equal to 0, that's going to be equal to 0 when the x value is 1. Set the bottom equal to 0, that will be 0 when the x value is 0. So those are the two critical values that we get. What do we need to do with these? Well, we're going to take those critical values and plug them into the original function. So f of 1 if we take f of 1, we will get 1 itself. F of 0 we get 0. And we also need to plug in the endpoints. So we need to plug in the endpoints of our interval. So -1. When we plug in -1, we will get an output of 5. And so, what do we have for this function? Well, there's an absolute max. It occurs with an x value of -1 and a y value of 5. And an absolute min shows up at 0, 0. So we check our function values at all of the critical numbers, and then we also check it at the endpoints themselves. All right, let's look at our second example. Here we have h of x is equal to secant of x. So let's first find the critical numbers. H prime of x. The derivative of secant is secant x tangent x. So just secant x tangent x. I don't know why I put secant squared there. And then we are going to set that equal to 0. But prior to setting it equal to 0, let's rewrite this in terms of sines and cosines. In terms of sines and cosines, this is sine x over cosine squared x. So this will be equal to 0 whenever the cosine is 0. This will be equal to 0 when the sine is equal to 0, or it will be undefined when cosine is 0. So that's going to occur at 0. You'll have at positive and negative pi over 2, but positive and negative pi over 2, those are outside of this interval. And so in that interval, the only critical value is 0. What are we going to do with this critical value? Well, we are going to evaluate this function. So our function h of 0, so we're plugging in 0 in here. This is secant of 0. Secant of 0 is 1. 1 over cosine 0, 1 over 1. We will also evaluate this at the endpoints. Negative pi over 6. When we plug in negative pi over 6, we are going to get 2 over the square root of 3. When we plug in pi over 3, we are going to get an output of 2. And so our absolute maximum is pi over 3, comma 2. Right? So it is 2, and it occurs at pi over 3. The absolute minimum is, our minimum is going to occur at 0, and it is 1. So those are the absolute max and mins of secant on this interval right here. Perfect. All right. In our next video, we will look at these last 2 examples. We will see you there.